Hi, I'm Timothy Brusella, and I have another simplex problem involving a standard maximum that I'd like to do for my Math 1324 class. And notice this is a standard maximum problem. Those are the ones that we're memorizing the steps for right now. Standard maximum. The simplex method will work for any sort of a linear programming problem for which there's a solution to be found, but the ones we're memorizing the steps for right now are standard maximum problems. They're maximizing the function. You have your non-negativity constraints, linear algebraic expression less than or equal to a non-negative number. So this is going to be a pretty long one, so let's get started. Set up the matrix. We have three decision variables, so we'll need a column for x1, x2, x3. How many slack variables will we need? Well, there are two less than or equal to constraints. Those are the number of slack variables. Each one gets a slack variable, and we need a column for z. 6, 1. Change the sign, -4. For x sub 2, we have a 3. What have we got there? A 0, right. Now, oh, by the way, remember you don't summarize that information on the simplex matrix. It's just an assumption that makes the process work. So we have a 3, 0. Change the sign, so -1. 12, 3. Change the sign, -3. Then zeroing out the columns. We have a 40, a 6, and what number goes down here? A 0. Remember, you move all those terms over to the left on the objective function. That's why those signs are negative there. And then you're left with just 0 on the right. You always start off with a 0 in that lower right-hand corner. We determine our pivot column. Which column is the pivot column? The most negative indicator. The number on you look at the last row, the most negative number. The negative number with the largest absolute value, that's your pivot column. The pivot row, you have to make a decision. 40 divided by 6 or 6 divided by 1. You want the smallest positive quotient. So you have 40 divided by 6. You have 40 divided by 6. That's what? 6 4/6, which is 6 2/3. Or 6 divided by 1. 6 divided by 1 is 6. You choose the smallest positive quotient. For the pivot column, you choose the most negative. Here you choose the smallest positive. So that would be 6. 6 divided by 1. Oh, this is a nice coincidence. The number that's common to the pivot row and pivot column is called the pivot, so we need to, we already have a pivot of 1. If it weren't a 1, we divide through to change it to a 1. It must be a 1, and it is a 1. We now pivot. We change the other numbers in the column to 0 using that 1. We're using the same operations we used when we were performing Gauss-Jordan elimination. -6 times row 1. No, -6 times row 2 plus row 1 gives me a new row 1. You can only multiply the row containing the pivot. And then, what operation will I write here to change the -4 to 0? You're having to change that 1. You're having to use that 1 there. So what operation am I going to write here to change that -4 to 0? Okay, it's a +4 times row 2 plus row 3 gives me a new row 3. So row 1 is not going to change now. Not row 1. Row 2 is not going to change. Let me write down row 2 right now. That's a 1. That's one of the pitfalls of this method, the way you have to keep recopying and be careful not to accidentally change things that you shouldn't. So, multiply by -6 and add it, that gives me a 0. Multiply by -6 and add it. Multiply by -6, that's a -18 plus 12, that's a -6. Multiply by -6 and add it. Multiply by -6 and add it. Multiply by -6, that's a -36. Add it to 40 to give you a +4. Now multiply by +4 and add it. Multiply by +4 and add it. Oh. Multiply by +4 and add it. Why did I say oh? That's going to become a 0 plus a -1. We still have a negative number on the last row. That means we're not going to be through. We're going to have to choose a whole new pivot column, a whole new pivot row, and pivot once again. Multiply by 4 and add it. That's a 12 minus 3, which is a 9. Multiply by 4 and add it. Multiply by 4 and add it. 4 and add it. Multiply by 4, that's a 24. Add it to 0 to give me a 24. But we are not finished with the process. We have to choose. We still have a negative number on the last row. We choose the most negative indicator. Well, the only negative indicator in this case is -1. Now we have to choose our pivot row. Which one will we use? 4 divided by 3 or 6 divided by 0? 4 divided by 3, that's 4/3, or 6 divided by 0. Wait a minute, what do we know about 6 divided by 0? Division by 0, is that even a number? No, division by 0 is undefined, so we can't even consider that one. The only quotient that's positive is 4/3. So row 1 will now be my pivot row. My pivot entry is a 3. My pivot is a 3. What do I need it to be? What do I need it to be? I need it to be a 1. In the first cycle, we already had a 1. Here, we don't have a 1. So how did we get those leading 1s when we were using Gauss-Jordan elimination? We'd multiply or divide. So I'm going to say row 1 divided by 3 gives me a new row 3. So the only row that's changing in this cycle is row 1. 0 divided by 3 is 0. 3 divided by 3 is 1. -6 divided by 3 is -2. 1 divided by 3 is 1/3. -6 divided by 3 is -2. 0 divided by 3 is 0. 4 divided by 3 is 4/3. The other two rows are not changing. So we recopy rows 2 and 3. So we recopy rows 2 and 3. Here's my pivot entry. That 3 became a 1. This isn't that bad. There's my pivot entry. It's that 1. I have to use that 1 to zero out the column. Well, I already have a 0 here. I need a 0 there. So we can say, what does this number need to be? So when I add it to -1, it gives me 0. Well, it needs to be a 1. It's already a 1. So row 1 plus row 3 gives me a new row 3. Recopy the first two rows . So I've recopied the first two rows. They're not changing. Add 0 plus 0 gives me a 0. 1 plus negative 1 is 0. Negative 2 plus 9, oh, that's a positive 7, good. Adding here, we get a positive 1/3. This is looking good. I think this may be the last cycle. Negative 2 plus 4 is a positive 2. 0 plus 1 is a positive 1. 4/3 plus 24. That's 24 plus 1 1/3. That's 25/3, which is what, 76/3? There are no remaining negative indicators. That means that we're through with the, we've found the maximum value. We're just ready to interpret the matrix. So we need to interpret our matrix. Remember how the columns were labeled. X1, X2, X3, S1, S2, and Z. So we had X1, X2, X3, and Z. And we had the slack variables, slack 1 and slack 2. Which ones will be set to 0? The ones you set to 0 have numbers other than 1, 1, all the rest 0. So X3 is going to be set to 0. S1 is going to be set to 0. S2 will be set to 0. The remaining values can be read from the numbers in the last column. X sub 1, you go down to the 1, you move across, so X sub 1 is 6. X sub 2, you go down to the 1, move across, X sub 2 is 4/3. And the all-important Z value, the biggest that Z can ever be subject to the constraints of this problem, is 76/3. 76/3. Remember, the variables that you set to 0 are the non-basic variables, and the variables that you read out from the numbers on the last column are your basic variables. I generally hardly ever use that terminology, though. I just call them the variables you set to 0 and the variables that you read out from the last column. So hopefully these 3 examples I've done in the videos have helped with your understanding of the simplex process, and I think now I am going to take a break. You know what I think I'll do? I like to box in my final answer. That says, to me, that says an unpleasant task is behind us and we're ready to move on. That's pop psychology, by the way. Anyway, bye-bye. Have fun with the simplex method.